Okay, everybody, we're going to do the can crush demo. So first things first, here's what you're going to need, or what I have rather, is I got a pan full of ice water, super cold, low energy. I got a Bunsen burner over here, sort of a camping Bunsen burner, I guess. And I have a seltzer water can. It's got a little bit of water in it. And what I'm going to do is I'm going to add a whole bunch of heat energy to this can. When I do that, it's going to go into the water. The water is going to get it really energized, and it's going to go from a liquid into a gas. When it does that, when it turns into a water vapor, it's going to take up way less space, or way more space. And as it does that, it's going to expand inside here, pushing the air out. Now, we talked about heat transfer and we talked about phase change. So as I'm adding energy, it's going to turn from a liquid into a vapor, and that's going to expand and take up all that extra space in here. Super full of energy. Now what I'm going to do is, once I see water vapor coming out of here in the form of steam, I'm going to take the can, I'm going to flip it over, and I'm going to put it back into this ice bath. Now what that's going to do is it's going to really quickly take that heat energy, and it's going to transfer it from the water vapor, and it's going to turn it into back into a liquid. Okay? So the whole point of this lab is for you to see what phase change and heat transfer has to do with pressure, high and low pressure. Since we're talking about like predicting weather, I want you to be thinking about, while you're watching this, what this might actually have to do with cloud formation, right? What is high pressure? How does high pressure influence the creation of a cloud, right? What role does it have to play with in terms of condensation? What does it have to do with evaporation, right? So I'm going to heat this up again until I see steam coming out of this can, and then that's an indicator to me that all the air has been pushed out, and all that's left is water vapor. Now, if we're thinking about this, water vapor takes up way more space than the same amount of water if it were in the form of an ice cube, right? Like an ice cube, you know the size of an ice cube. If we took all of that water and we superheated it so it went through the liquid phase and then into the gaseous phase, the space that water vapor takes up is way more than the solid or liquid phase. So right now what I'm doing is I'm heating it up. I can hear it boiling in this can. And as I do that, I am pushing out all the air because of the vapor that's now filling the top part of this can. And once I put it into the ice bath, I'm going to switch the heat transfer, and it's going to go from the hot steam into the cold water, and that steam, that vapor, is going to turn really quick back into a liquid. Okay, so here we go. You ready? Awesome. So, what I want you to think about is what role pressure might have, high or low, along with weather. Thanks for watching, everybody. Happy science.